Welcome everyone. Today we are going to use the correlation coefficient to measure the interrelation and the connection between two different variables in Excel. And we are going to, I am going to show you how to calculate the correlation coefficient in Excel with a familiar database. But first, we are going to familiar with and I'm going to introduce you some theoretical views and theoretical approach um, in um, in the correlation coefficients. First of all, and very important thing, the measuring scales, because in the past practices we dealt with some variables, some ratios, but there are another three types of measuring scales. For example, nominal, ordinal, and interval. The level of measurement or scale of measure is a classification that describes the nature of information within the values assigned to a variable. Psychologist Stanley Smith Stevens developed the best known classification with four levels or scales of measurements: nominal, ordinal, interval, and ratio. For example, the population number, or population density, or GDP per capita, all of them are ratio variables. But there are some other scales of measurements. For example, the nominal value, which we use to differentiate between the observational units. For example, people. For example, we have attributes for the sex, men or women, or for example, when the observational units like cars or bicycles, we can determine the color of them. But in the nominal scale, in the nominal value, we cannot use these values for measure which is the biggest, which is bigger, or how many times bigger one observational units. We only use for differentiate between them. And there is another scale of measurement, the ordinal value, in which we have only a rank order, which is the first of, for example, GDP per capita, and which is the last one, which is the second one. For example, the marks is a very good example for this. We only know about the ranking. 5 is better than 4 or 3, but we don't know how much bigger, how much better one and another. And here is the interval, which is for example, age intervals in census data. We know how much bigger one and other, but we cannot use for a division, for example, for the interval scales of measure. But the ratio we can use Um, in the ratio scales we can use the division of it, because for example, if we have a population number of each observational unit, or um, um, not observational unit, geographical unit, we can calculate how much bigger and how much larger a number of population in them between two observational units. Okay, uh, with the between the ratio variables, we can um, measure the interrelation and the relationship between two ratio measurements. We can use the Pearson correlation. Here it is. This is the Pearson correlation coefficient, and here is the formula. Um, you you don't have to um, remember all of the formula. Just understand the way of calculation and the logic of the calculation. Um, Here it is the below. Um, Here it is in the denominator. We use the standard deviations of the two variables, because this is the formula of the standard deviation of the x, and this is the formula of for the standard deviation of the y variables. And in the denominator we use a multiplication between the differences of a given variable between the average. And if we have the same direction differences, for example, um, the given variable is higher than the average in x, and those spatial unit we have a higher y value as well. We have positive positive value in there. So if we have a positive Pearson correlation, we have a strong positive correlation between the variables, which means that both variables take their high and low values in the same place. There is a direct proportionality between two variables. But if we have a negative correlation, the connection between the variables it's the opposite way. For example, unemployment rate and GDP per capita. If we have a high GDP per capita, very likely we have very low number of unemployment rate, and the opposite direction is it's true. After that, if we deal with not ratio, if we have ordinal value, if we just know the rank order of the given variables, we can use the Spearman rank correlation, which formula we have, but we not going to use this in Excel, but this is good to know if you have in the future, if you have rank or ordinal number and you want to make a connection and make a calculation to the measure the connection between the variables. And here it is, the graphs between the ideal graphs between two variables. For example, here it is. This is a number of the correlation coefficient. For example, if we have 1 for the correlation coefficient, we have an ideal connection and the relationship between the two variables, because from one variable we can calculate with which one function we can calculate the other variable, because if we just select one unit, we can calculate the number of the other value from it. But in the nature or in the real world, we have sporadic view of these graphs, and this is also a very high relationship between the variables. And here it is, the zero means that there is no any relationship and there is no any connection between two variables. And here it is, the minus, the negative one variable, the negative one correlation. If we have very low number of the one variable, we have a high value the other and the opposite way. Okay, and after that we can calculate the correlation coefficient in Excel. First of all, we have to calculate the relative variables from population, the unemployed people, and the GDP as well. So we have to calculate the population density, the unemployment rate, and the GDP per capita as well. Insert a new column. Okay, population density 2006, and make a division between the population and the area. Okay, population density 2010. Okay, and population density 2015. Divided by the area. Okay, first of all, if we want to make such graphs for two variables, we can make in the Excel. For example, select the population density at 2006 and population density in 2015 with a control button. Select all of the cells and insert, and in the charts insert a scatter and the first. Okay, and we have a very huge connection and very huge relationship between these two variables. So there isn't a huge rearrangement with population density. Not the rural area for not the rural area moved in the population and the people, but we have a very huge outlier in Prague. So if in the correlation, because we deal with differences between the absolute differences between the average, the outlier is the correlation coefficient is very sensitive for the outliers, so we have to exclude from the analysis. Just make a selection below, and here it is. We have a scatter plot for the population density at 2006 and 2015, and if we want to calculate the correlation between these two variables, just select an empty cell and equal sign correl, and select these two variable array, dot comma, and also these two, and close bracket, and we have a very huge correlation coefficient, almost 1. So there is a huge connection, there is a huge relationship between the two appointment with population density. So there wasn't any huge rearrangement in those 10 years. There wasn't any developing and huge developing urban area or any kind of these two. Okay. Let's see about the unemployment rate. Insert column. Unemployment rate 2006. Unemployment rate 2010. Unemployment rate 2015. Okay. Make a division between the unemployed people and the population, that appointment, and make a percentage form, so multiply by 100. Okay, and delete the empty for the empty row, because we don't know how much unemployed people in there in Mazovian. Okay, same as population 2010. Okay, good looking form, the unemployment rate. Okay, here it is. just delete. Okay, we have an unemployment rate, and we are looking for the relationship between the unemployment rate and population density. For example, population density, select the population density at 2015 and the unemployment rate 2015. Okay, and make such chart. Okay, and again we have an outlier value, so we have to be lower. In this case, we have a not huge relationship between them, because between the population density and between the unemployment rate, we have a very weak relationship between them. We have a very low population density. For example, rural area. These units are rural area below 100 people per square kilometer. These are the rural area, and we have the high percentage of unemployment rate in the rural area, just in the rural area, but we have a very low number of unemployment rate in the rural area as well. In the urban area, we have a moderate number of unemployment rate. Okay, so if we just make a correlation between these two, careful not select the outlier. Okay, and dot comma. Okay, close bracket. Yeah, we have a lower number of correlation rate. We have weak number of correlation rate, according to weak positive in between the unemployment rate and the population density, because there are several rural area with a lower number of unemployment rate. But if we are curious about the economic growth or economic performance, we can calculate with the GDP. So we would like to measure the connection between the economic performance and population density or unemployment rate. For example, insert a new column. Okay, and let's calculate the GDP per capita 2006. Okay, make a division by population and multiply by 1 million. Okay, GDP per capita 2010. GDP per capita 2015 division by population. Yeah. Okay. First of all, make a graph between the GDP per capita and population density. And we have two outliers. Two at 30,000, 35,000 with GDP. So delete this, and looking forward, Prague is the outlier, and Bratislava, the two capital, the capital of Slovakia and the capital of Czechia. So we have to make a copy and open a new sheet. No. Yeah. Open a new sheet. Code name population density. Yeah, and GDP per capita. Okay, and let's delete these two units and make graph for the filtered variables. Okay, we have a moderate positive correlation, but calculate the number of the correlation between the population density and GDP per capita, so economic performance. We have a moderate correlation between them. So in the rural area, the economic performance is low, and in the urban area, there are the concentration of the jobs and the concentration of the GDP in the urban area, the high density of the built up with high density. So we can measure the degree of the relationship between the economic performance and the population density, so the urban and the rural division as well. Okay, but after that we can measure the correlation between the GDP per capita and the unemployment rate as well. Just insert a new chart. Yeah. We have two outlier as well, so we have to select and copy the unemployment rate and the GDP per capita as well. Control C and right click and value copy. Okay, and delete the two outliers, Bratislava and Prague, and the empty number as well. And we can draw such charts. We have a negative relationship between the unemployment rate and the GDP per capita. So we can make such a correlation. Yeah. Okay, dot comma. And here it is. We have a negative 0.4 between a moderate, between a weak correlation number between an unemployment rate and GDP per capita, but we can measure the degree of it. Okay, so this was the correlation calculation. This is for the measure the degree of the connections, the interrelations between two variables. So let's practice the other relative variables. Make a graph to detect the outliers, and after that delete the outliers and calculate the correlation coefficient. Okay, next time we will deal with the regression analysis, which is developed correlation analysis.